Now I'm going to formally introduce strings. We've already been using strings. In my statements video, I think I pointed out this, that every time I write something like this, let me add a variable in here, or when I did this, we're using strings. So we can see what they print. But using this format specifier or this type of formatting, these are string operations, not print operations. So I could have done this. Let me change X. X will now be 99 just to make it more clear in the output. So these are strings. So this is the string, this is a string operation, and this is a string operation. But that's what I've been working with up till now. So how do we formally create a string other than what I just showed you? Well, I can enclose characters within single quotes or double quotes or sets of double quotes or single quotes, where the set is 3 double quotes on each end or 3 single quotes on both ends. What's the difference in these? Well, the first two are basically the same. The third one, though, allows me to break the string across lines. Because if I do this, double quote, this is a string on multiple lines, the interpreter has a problem with the new line that's right here. So if instead I do this, whoops, I created it but I didn't print it. And there it is across multiple lines. And we've already seen this, that comments can be written using sets of triple quotes. Now my program does nothing except to have a comment. All right, so that's legal. The nice thing, though, about being able to use double quotes or single quotes is when, as part of the string, I want to have a single quote or double quote. So let's say A is equal to, it's going to be hot today. Ralph said, these would be single quotes. Program is fine, and let's print these. It's going to be a hot day, Ralph. It's probably fun. So why did I need to do that? Well, let's say I'd done this. Put the quote there and here. See how the colors change, indicating where the string stops? It thinks this is the string because it looks for the matching quote character. And that's where it found it. So as we saw earlier, by being able to use single and double quotes, then I can do this. And we don't have to do things like that. That's another option where I'm escaping it. So when I escape a character, it says use the following character in a special way other than a standard way. We do that every time we put new lines in here. So if I do this, that says don't print an end, instead print a new line, and see I get the extra blank line there. So there's lots of things that can be escaped, including the backslash itself. So strings are really just collections of characters. And internally, every character has a numerical value. Now, historically, those numerical values corresponded to characters from some character set, and probably the most popular of those is what's called the Ascii Character Set, where the A stands for American. Now, keep in mind that ASCII came out in the 1960s. So there was a couple issues with this. The first is, since A stood for American, the characters that were included in the ASCII character set were for the American language, like what I'm typing. So you couldn't represent other languages easily. The other thing, though, is that because memory was much smaller at the time and more costly, ASCII character sets were stored in a single byte, and I haven't really defined what that is, but a byte is fairly small by modern standards. We still use bytes, but ASCII characters were stored in a single byte, which meant that the ASCII character set only included 128 characters. Now, a byte can actually store 256 different things, so we could add another 128 symbols to produce extended ASCII if we want. Python supports Unicode, which as of March 2020, and I'm creating this video in August of 2020, but as of March 2020, Unicode supports 143,859 characters, which means it can represent many, many different languages. We'll look at both of these here in a second, but one of the things to keep in mind before we leave this slide is that strings that look like numbers are not numbers. So this string is not the same as this integer. Let's look at those. Here's the ASCII character set. And so as I said, we have 128 different symbols starting at a decimal value of 0 and going to a decimal value of 127. These other columns are the same numbers but in base 16 hexadecimal and base 8, which is octal. This is decimal, which is base 10. So here's a null character, here's a line feed and carriage return, and those are used by different operating systems to produce the new line like I have here. Different operating systems use different combinations of those. Here's the visible characters as we think of them. A space has an ASCII value of 32. Here's the digit characters. So when I write 1, 2, 3, I'm using these digit characters 1, 2, and 3, which have ASCII values of 49, 50, and 51 respectively. Here's the uppercase letters of the English alphabet. Capital A to capital Z starts at 65. Lowercase a to lowercase z begins at 97. So these differ by a value of 32. 65 and 32 is 97. 90 plus 32 is 122. What about Unicode? Well, here's Arabic characters and their Unicode values. If we go look at some of the others, here's some other characters from the Cyrillic characters. Here's Greek extended. Here's some other characters, and here's some Greek characters. They have hieroglyphics can be represented. So if you speak a language other than English, you may recognize many of these characters, right? But the beginning of Unicode, as far as I know, matches up with ASCII. So we go up here. So this would be extended ASCII. So you can represent some things, a quarter, a half, the pound sign, the cent symbol. Here's those characters from the beginning of ASCII I've showed you. Lowercase letters, uppercase letters, digit characters, the space, things like that. And going back to the history of Unicode, you can see here it started in 1991, right? It had support for 7,000 characters. And now, as of March 2020, like I said, it's 143,000, right? We can compare strings using our relational operators, just like we did numbers. So let's look at that. So A is equal to cat, B is equal to car, C is is equal to capital Cat. And let's see what we get when we compare these. These have truth values, so A equal A compared to B. We don't need to see C actually, because it'll be just like A and B. Less than A, or excuse me, B. Let's see what character or results we get when we look at these. And I'm going to put the truth values next to these to make it easier for us to talk about them. So these are coming from this window. So how does this work? Well, it's doing a character by character comparison. So it's really as they would sort in the dictionary if you keep in mind ASCII values. And as I showed you here, capital A has a smaller ASCII value than small a. Okay? But then beyond that, they're in the order. So lowercase a comes before lowercase c, which comes before lowercase s, and so forth. So what do we have here? Was A equal to A? Yeah, cat is equal to cat. But is A equal B? Well, no, because the T and the R differ. So that's false. What about these relationships? Cat is not less than B because T doesn't come before the R, right? Here's lowercase t, here's lowercase r. So R came before T, so A is greater than B. What about A being less than C? Well, it's comparing lowercase c to capital C. And we know that lowercase c has an ASCII value of 99, but uppercase C has an ASCII value of 67. So A is not less than C. But A is greater than C because cat spelled this way comes after cat spelled this way. That's how it compares. Right? We can concatenate strings. That is, we can add them. So here I create 3 strings, Darren, space, and Brazil, and I just add them together with the plus symbol. So we say that the plus symbol has been overloaded, which means that the Python interpreter looks at the types of things you're trying to add, and it has been told that when you add 2 strings, you don't try to add the D and the B. Instead, add means to add to the end. And even though I didn't show you this in my list video, we can concatenate list. So A is equal to 1, 2, and B is equal to 3, 4. So C is equal to A plus B does this. It's similar to what we do with strings here. Whoops, I printed A. Let's print C. And now I've added the 2 in the sense of adding to the end, or concatenating. It's concatenated this one and this one as opposed to 1 and 3 and 2 and 4. All right? You can't do that in the normal sense with basic Python. So strings are really sequences of characters, which means we can manipulate them similar to what we've done with lists. But we're going to see an example in a moment that shows that they're not entirely the same. But one of the things in which they are similar is to use indexing and slicing. So if this is word, then word 0 is A, word 1 is B, and word 2 is C, which we see here. But I also can use indexing coming from the right end. So Z has an index of -1. Y has an index of -2, and X has an index of -3, just like they would if they were inside a list. Here I'm slicing, so I've added these comments so we can easily see what the indexes are, and this means this is where 10 is at, and this is where 20 is at. So this says, show me the letters from 3 to less than 10 in steps of 1, because that's the default. So it goes from 3, 4, 5, up to 9. So 3 is D, 9 is J, and we get this right here. This says start at the beginning while less than 8 in steps of 1. So I'm going to go from 0 to 7, which is H. I get this. this says start at 10 till the end. Starts at the K, goes to the end. So K to Z. And finally, this says starting at 4 in steps of 2 while less than 15, give me those characters. So 4 is E, we skip the 5, we get 6 here, which is G, skip the 7, we get the I, and so forth. We stop at 14, which is O, so I get this right here. So how do strings differ from lists? Strings are immutable, which means I cannot change a string. So when I try to change the C, which has an index of 2, and try to change it to the capital X, I get this error message. So how do we change it? Well, we can't. But what I can do is produce a new string that has this character at that place. And so here I'm just going to reuse that name, S, just like I can say over here. I can say A is equal to 1, 2, 3, and then say A is equal to 99. That's legal. I just reuse the name A. I can say S is equal to cat. S is equal to dog. So print S. It no longer thinks it's cat, and since I never said print it when it's cat, I never see that. Now S is dog. Well, I'm doing the same type of thing here. So I've added this comment here to show us what this slicing does. So this says start at the beginning while less than 2, so it gives me the 0 and 1 indices, that's AB. Here it says start at index 3 and go to the end. So it's starting at the D and goes to the end, so it's D, E, F, G. So I concatenate the strings AB, X, and D, E, F, G to get this. So finally, let's look at some string methods. There's many string methods. I'm going to show you just some of these because they're some of the ones I've used most often. And there's also a linked function, just like there's a linked for lists. And to say what I was just saying, A is equal to 1, 2, 3, 4, 5, 6. Three characters, 6 elements of this list. All right? So if we were to look briefly at these built-in types for strings, these are some of the methods: uppercase, translate, title, which means capitalize each word, strip, I'll show you that here in a second because I use that a lot, split, or split's actually the one I use a lot, replace, characters convert to lower. So these are all methods. So you write the string name, dot, and then the method name, and then in some cases you can pass it something, and it produces a new string. So let's look at these. So here's my string, and I have some spaces at the beginning as well as spaces at the end. So we call those white space, right? And so to print the string, including the white space, I put these vertical bars here just to make it obvious where the white space is. And here's the length function telling us how many characters we see. So it says this string between the vertical bars has 14 characters. I'm going to use strip now to eliminate the white space. And so by default, it eliminates spaces and new lines and things like that. Tabs would be white space. So there's 2 characters here, 2 characters here. So afterwards, when I save this to T, T now has 10 characters. And we can see the white space from the ends is gone, but this space is still here. I can print what T would look like if I converted to lowercase, but I did not change T. If I want the new version, I would have to assign it a value just like I did when I changed S and saved it as T. So in lowercase, I get this. One of the things I use a lot, though, is called tokenization. And to tokenize, I want to identify the tokens within the strings. When you look at a sentence like this, tokenize T with the default delimiter of a space, as an English reader, I'm looking at the spaces as my delimiter or separator to separate the words. So when I tokenize, I'm trying to divide the string into tokens based upon some delimiter. But we're not limited to a space as a delimiter. That is the default. So when I print t.split, you can see it gives me a list in which the single space that's there separates this string from this string. So I got two new strings. But if I say use a lowercase x as the delimiter, well, there's an x, but the space is no longer treated as a delimiter. So now I get A, B, C, D, space, E, F, and G as the tokens. And then sometimes I want to take a string and center it. Maybe I'm producing a report or something like that. So I want to center it and pad on the left and right with spaces. So I can do that here. I'm going to use my vertical bars again to show where the spacing is at. So t.center says center it within 30 characters. And since it had 10 characters, I'm going to add 10 to each end. So there's 10 spaces. My string, 10 more spaces. So that's some of the ways you use strings. And we'll see those throughout some of the remaining videos. If you find videos like this helpful, please hit the subscribe button as well as the like button, since that will help me out.